Okay, class, so the following video is recorded to help you get familiar with MATLAB, and I'll also use this video to walk through the um, the MATLAB commands we'll use in the first assignment of MATLAB for this course. So for this specific view, I'm going to use the Yukon Skybox, which is a free service provided by Yukon to us to access some of the softwares on the cloud that you don't have to install on your local computer. Um, so this is I already logged in my Skybox to use MATLAB, so this is where I am already. And I'm also having my Husky City open, and in our course, you go to course content. You should have already seen this MATLAB assignments folder, and into that you have the MATLAB assignment. Now for this link, you can directly access it, and you should turn in your assignment using ASCII City only. Okay. Now you have attached file, so you can click and download, and this is going to be the one. I'll save it to my local drive so it'll be easier for me to explain all the things. I'll save it here. I'll have it open. Okay, so I'm going to also full screen this part so we'll have larger real estate space to use. Okay. So now I have the document open, and I have my MATLAB file open. Okay. Both of them under my Husky City, and this is the MATLAB I was talking about. Okay. So this is the interface of MATLAB. It's actually, if you look at the interface itself, it's very complicated, but using MATLAB isn't too difficult. Now, running a command in MATLAB can be done through two means. One is to type something in the command window. You see this command window is right here. Another is to write a script, basically a file, and run from the file, which usually is more convenient for to manage the code. I'll do a quick demonstration of both. So MATLAB is a very simple programming language. When you use it, you have to define variables, assign values to the variables, and perform all kinds of calculations using the built-in commands. Okay. So to start with, let's see how to use MATLAB to define variable. Let's say I want to define variable a, just step a, equal to, let's say I want it to be equal to 5, so I put 5. If I press enter, it will tell me, well, a is equal to 5. Okay. And on the right, if you look at your workspace, you have your variable a and tells you the value is 5. This is for single value variable, and you can also define a vector or a matrix. In our case, a vector will be very useful. A vector will be an array of values. For instance, I can define b equal to an array will be 1, let's say 3, 4. So this is a vector that contains 4 values. If I press enter, okay, now I can see b equal to, this vector has 4 values, and on the right you have b equal to, okay, this vector with 4 values. Now sometimes you want to construct the vector to follow a certain pattern. For instance, you want your vector to be from 1 to 10, so it'll be 1, 2, 3, 4, 5, 6, 7, 8. And in that case, you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Close the bracket. That will give you this one. But it's too complicated. What if I wanted from 1 to 100? Now, in MATLAB, it would be easier. You only have to define your variable in the following sense. Using three numbers. The first being the starting number, I want 1. Will be a column. The middle one will be the increment, kind of the step size. In this case, every time I want to increase it by 1, so put 1. And then the last one will be which is the last value you want to see in this array. In this case, 110. Press enter. I have exactly the same vector, but of course I define it using a much simpler way. Okay. This is how I define a vector. And of course, you can also do other multiplication, not other calculation. For instance, I want to double it. I want to multiply everything in this vector by 2. So 2 times d. Now you can see I have 2, 4, 6, 8, 10, 12, and so on. I can also square it. But in this case, if you do this square d raised to the power 2, you'll run into an error because in MATLAB, MAT stands for matrix. So all the calculations has to be done in terms of a matrix. In matrix, you cannot simply square an array. Okay? The dimension must match. If what you want is to square every element in this vector, you need to have a dot in front of this operation. So if you add d dot raised to power 2 and press enter, I'll have 1 square, 4, 2 square, 9, 3 square, 4 square, 5 square, 6 square, and so on. And I can do other calculations. For instance, I can apply a sinusoidal function of d. So this will calculate out the sinusoidal. So it will be sine of 1, sine of 2, sine of 3, sine of 4, 5, 6, 7, up to 10. Okay. Now, in terms of signal, how do we define a signal? Because we're going to use signals in this lab. Now, for signals, first of all, you wanted to define your time axis, right? Time axis can be also a range, let's say from -5 to 5. But in MATLAB, everything has to be numbers, so the time axis from -5, and because this computer cannot do continuous, I have to specify all the points along your time axis. So I want it to be a very fine axis. So the step size will be 0.01 and 5. So this will be a time axis from -5 to 5. Now if I press enter, basically you will see all the values contained in this particular vector. Okay, so it will be from 5, 4.99, 4.98, and so on. And on the right you can see I have a t vector. It is having 1001 variables. Oh, I'm sorry, 1001 numbers. It's very long. Sometimes you want to make it a little short, so and you don't want to see all these intermediate values appearing to take all so much space. In that case, you add the semicolon. If I press enter, it doesn't show anything, but the system itself remembers, well, I have this t vector. Okay. And you can do sine of t. Okay. And we can define a function y, a new vector basically, equal to sine of t. Then you have a semicolon, you have enter. Doesn't show anything in the command window, but on the right hand side you have this y defined. And you want to check, well, is it actually the sine function I have in mind? What to do is to plot it. And you use the plot command. First put in your x-axis, which will be your t, then your vertical axis, which will be your y. Press enter again. Now this window pop out, you see this figure, you see the sinusoidal curve, and it's from -5 to +5. Because you're having this axis with very fine resolution, the curves are continuous, and you can regard it as a continuous time signal. Okay? So these are some of the basics. So with that being said, let's see what happens to our lab. That's where I see. Let me open this one again. Okay, there we go. So this is the lab we're looking at. Okay, it's all about signals. And as you can see, I have mentioned, the goal of this lab is to have you learn to use MATLAB to visualize various signals and various methods and knowledge we have learned. You don't have to be very proficient. What you only need to do is to type in a few commands and see what happens. I give some examples and we will look at what are they. Now for the first line of this example, you're very familiar with this command, we just use it. We define my time axis, my time interval from -10 to 10 with a step size of 0.01. It's a really fine axis. Now whenever you see this percentage sign, it represents comment. So everything after this sign will be ignored by the program, but it's put in there just as a reminder to the reader, to the programmer, well, this is what I use this line for, use the command for. And then I define a signal as y equals 2 times sine 3t plus pi over 6. Now pi is a variable reserved in MATLAB, so if you go to MATLAB, you type in pi, I'll give you 3.1416. This is the pi constant we're looking for. Okay. Now, as I mentioned, there is another way to run MATLAB command, is to have a script. So let me copy this, and let me show you how to run the script from MATLAB. And it's very simple. You go to the left corner and use top left corner to see this new script. So click on it, initialize something new. If you don't want to see a very crowded window, you can undock it. So this is what I will usually do. Now I'll paste whatever I have into this window. So this is what I have. Now sometimes, to make things simpler, I use clear command. This is used here to clear all variables in the workspace. So we're starting something new. All the variables defined earlier will be wiped out. And sometimes you see, I'll see this will clear the command window. So remember when we have our MATLAB, if we go back, you have already a bunch of things in the command window. Okay. If you want to clear all that, what you do is to type CLC, enter, and it's all clear. And look at all those variables on the right hand side in the workspace. If I use clear, they're all gone, wiped. The memory is wiped. So let's come back. Now, if you directly run it, it will tell you that you have to save it first. So let me save this script. You can choose whatever you want To save, I'll save it to my particular file. Okay. I'll name it to be example 1 lab 1. I'll save it. Now you see the name of the file has been changed. Now I can run it. The only way to run, or the easiest way, is to find this green arrow. It says run, and I'll just press run. It asks me, okay, this is not in the current folder of the MATLAB path where it used to find out the commands to run. Well, usually what I would do, for simplicity, is just to change folder such that the MATLAB will directly look at all the commands in the folder where this file is saved. So change folder. So change the working folder. MATLAB run in the background. Meanwhile, you can see T, the new variable is defined, Y, this new function is defined, and this figure has been updated. Okay. The sinusoidal signal, but with higher frequency, higher oscillation frequency. So using 3 lines, we can construct a sinusoidal signal direct simply in MATLAB. And this is our example number 1. Okay, this is the one. Now, as I mentioned, well, this figure that you're showing has very small numbers or text size on these 2 axes, and if you want to increase it, for instance, to a larger font size, I provide a way to do that. Simply use a few more commands. So I'll copy those code into this part first. Okay. Now this is not recognized. It should be the single quotation mark. Well, this is the Word file, and the PDF file modified that character, so I have to retype it, but it's just the single quotation mark. After we make some changes, you'll see the stars. I'll save them again. Now, I'll make this a little narrower so we can look at the change. Now, I added 3 lines of code. First line of code says y_lim. This is the y limit. The limit on the y-axis currently is from -2 to 2, and I would like it to go from -2.2 to 2.2, so I leave some margin on top and underneath to find the limiting values. Secondly, I want the font size to be a little bit larger, to run it to 18, such that this text becomes larger. And I want to add some grid to the graph, and I want to add a legend y of t. So now what you can do is to rerun everything, look at this green arrow and rerun it. But since we only need to run these 4 lines, what you can do to select these 4 lines using your mouse, right click and look at this one. Set evaluate selection, meaning you would only run the code currently being selected. So we'll do this. And you can see the change on the right directly. The y-axis is being changed. You have some margins on top and underneath. The font size are increased, and you have this box legend says, well, the blue curve represents y of t. Okay. This is our first example. And I'll encourage you to run this by yourself to see how everything goes. And there are some special signals. Okay. Sinusoidal cosine, sine, cosine can be used. This is the first example. We can also use the unit step, which is called the Heaviside function. Now all we can do is like this. We'll copy this part. We can, let's say, run another example, another file. So we'll create in this editor. We'll add create new document. Now paste. And again, if you don't want, if you want to wipe out what has been generated in the workspace or in the command window, just use these two. We save. I'll name it to example 2 lab 1, and I can run it all the way from the top. Okay, let's see what's I look at YSA double. So how do we solve this?